Now, the worst thing you can do with any of these proof questions is to start moving things around between the sides. You've got to treat the equal sign as a barrier. You can't pass terms from one side to another. We've got to work on left-hand side versus right-hand side. Let's start fiddling with the left-hand side and start multiplying this guy out. So what do we get? I can at least now take a common 4 out of all of this. So this is 4a squared minus a minus b squared plus b. So let's now have a look at what the right-hand side turns into. Yes, we've got a 4 again, outside everything. Multiplying everything by a, we get a squared plus ab minus a minus ab minus b squared plus b. Well, the ab terms disappear, so we get 4a squared minus a minus b squared plus b. And as you can see, the left-hand side is the same as the right-hand side, so we've proved the relationship as required. So let's come over here and look at part B, and we've been asked to prove that the difference between the squares of any two odd numbers is a multiple of 8. You may assume that any odd number can be written in the form of 2r minus 1. So if we take that odd number, 2r minus 1, and square it, and then subtract another odd number, squared, and we've got to prove that this relationship is divisible by 8. Well, from what we've done in part A, we know this, using r's and n's, is equal to 4r minus n. Well, it's certainly divisible by 4, but can we say it's divisible by 8? Going back to the start, we know that 2r minus 1 is odd and 2n minus 1 is also odd, but we don't know whether r or n are either odd or even. And the trick is, now we've got down to here, is that if either this term or this term are even, you see, if a number is even, I can take a factor of 2 out, turning this 4 into an 8. So if I can prove for all cases of r being odd or even and n being odd or even, and if I can prove that either of these terms remains even, we're home. So I've set up a table here with all the combinations of r and n, and I've numbered our two terms 1 and 2. Now if r is even and n is even, in term 2, even plus even will be even, but the negative 1 turns this term odd. But take away an even number from an even number, the result will be even. So we're okay for the first of our combinations. So let's look at line 2. R is even, n is odd. Well, if that is true, then r plus n must be odd. But taking 1 away from that odd number, this must be even. An even number taking away an odd number, this term now goes to odd. Now what about if they're both odd? If we take an odd number away from an odd number, our result will be even. If we add an odd number to an odd number, this result will be even, but then taking away 1 will turn it odd. So again, we're okay here, and I forgot to add a tick for the even from the second of our options. Now the fourth. R is odd and n is even. Again, if we add an even number to an odd number, this will be odd, but taking away 1 will turn the result even. So in this case, term 2 will be even and term 1 will be odd. And yet again, we've got an even. So in all 4 cases of r and n being either odd or even, we've found an even result from our formula. So therefore we can say 4r minus n, r plus n minus 1 is divisible by 8. And there is the proof.